Howdy ho, here we go. Ready for another homework demo video. Way too much rhyming. Okay, we're on Unit 2, Homework 4. Let's get going. This unit is very calculator friendly. So when we learn to combine decimals, it's very much the same as when we learn to combine integers. The first thing we have to figure out is if we add or subtract, and the next thing we need to know is our answer going to be positive or negative? Here's how we figure those things out. Look in front of the number. If there's a negative sign in front of the number, that number is negative. So our 2.1 is a negative number. I'm hoping I can make it red. There we go. 8.92 is positive because it has a positive sign in front of it. When you have two different signs, you have to subtract. And if you think about that, it's like owing somebody $2.10, but you have $8.92 in your pocket. So once you even it out and pay back that person, you would obviously subtract the 2.1 from 8.92, even though it says to add in the middle. So it's because the two signs are different that we need to subtract for this problem. I'm doing it in my calculator because decimals, I will just make mistakes that I don't want to make. So I'm putting in 8.92 minus 2.1. Now that might not be the same way you did it. I thought of it that way. You could type this into the calculator exactly as you see it. And if you do, you will need to use the little negative sign here at the bottom of the calculator that has a parenthesis. However, I want to caution you that if you have to know how to combine integers, and you need to know when to add and subtract and whether your answer is positive or negative. So if you're using your calculator to figure that out for you, you will find quickly that you're going to be in a funky place where you don't have a clue what's going on. So please don't let that happen. Please pay attention to your signs and ask yourself, does this problem tell me to add or subtract? Then if you want to put it in your calculator to do the quick part, fine, no problem. Let's look at this one, negative 2.1. And I know that you would say that looks like subtraction. The way I think of it is there is a negative sign in front of the number, and therefore that number is negative. When we have two negative numbers, you owe both two people. You don't have any money, and you need to add together that debt. So when I have two positives, I add and get a positive. If I have two negatives, I'm going to add and get a negative. So again, using my calculator and just saying, okay, I know 2.1 needs to be added to 8.92, and I'm getting 11.02. So I owe a total of $11.02, and it is owing, so it's a negative 11.02. One more time, when the signs are the same, we add, and we keep the sign. Adding negatives gives us more negatives. Now this guy in the middle, he's a goofy guy. He has two signs, and that can be very confusing unless you remember that anytime you see two negative signs together or two negative signs that are being multiplied, it's like a not, and they turn into one positive sign. It's saying I am not going to the store. Not going is going. It's that double negative. I sometimes think of it as I am not subtracting. However it works for you, when you see two negatives right together, they become a positive. That means 8.92 is a positive number. 2.1 is a positive number. And as confusing as that might look to you, we're really just adding the two numbers. They're both positive, and so we get positive 11.02. Last one here, 2.01 has no sign in front of it, therefore it must be positive. 8.92 has a negative in front of it. I now have one positive and one negative. My signs are different, and when the signs are different, I know I need to subtract. So I subtract the two numbers, and I get 6.82. But then I notice, oh, the 8.92 is negative. It's also the larger of the two numbers. So when I subtract the two, I'm going to have negatives left over. In other words, I owe more. So when I'm done, I still owe because I owe more than I really have. Hope that's not happening in your bank account like it's happening in mine sometimes. All right, we need to keep those rules straight so that we can evaluate when things are positive or negative. When I deal with fractions, I really like my fraction bars straight. So it helps me decide what's on top and what's on bottom. So as I do this problem, I'm going to straighten them out. This says evaluate, and then it tells me if y equals 2/3. So it simply wants me to take that 2/3, put it in place of the y. So I wrote my 1/3. I'm now going to write 2/3 minus 2/5, and this is the problem that I need to do. I can mess with common denominators. Or I can say, I want to mess with common denominators and pop my calculator up. If I put this in my calculator, I need to make sure and put all the parentheses, put parentheses around the fractions every time I write a fraction. I say this a lot, you don't have to have them, but there are times that you need them, and if you don't put them in when you need them, everything messes up. So it is my policy to sneak parentheses in, just like that, when I put a fraction in my calculator. So I'm going to go ahead and pop this in, parentheses 1 divided by 3 in parentheses plus. Look how I have 2 parentheses in a row. That's quite all right. 2 divided by 3, remember that fraction bar is a division. Then in my parentheses minus, begin parentheses, 2 divided by 5. In parentheses twice again at the end. When I press enter, I get 0.6. Well, I might look at that and think, I wish I knew how to make that into a fraction. Well, I know how to make it into a fraction. Some of you do too. If it's 0.6, it's 6/10. So 6/10 reduced to 3/5. Don't like doing that? Forgot how? No problem. Tell your calculator to do it for you. And you do that by pressing the mouse button. After the 0.6 is an answer, then you press the mouse button. Choose enter twice to turn it into a fraction, and you'll get 3/5 right out of your calculator. I hope you're working with those calculators. You can see that they are very handy dandy, trusty, nifty things. Listed below are my points for a game. I need to know my overall score. So this is the same kind of setup where I have negative numbers that I need to add together, and then I have some positive numbers that I need to add together. Normally, I should say, do this one step at a time and subtract the negatives and then add and then subtract. But most people make fewer mistakes in adding. So what I recommend is that you add your negatives together. I get 4.6 and 2.4. And together, that is 7. But it's negative, so together it's -7. Now I'm going to put together all my positive numbers. 2.8 plus 2.4. Whoop. Nope. 2.8, watch me go. And I'm backing up. I need 3.9 for this positive guy. And then 2.2 plus 2.2 for the last one. And I get 8.9. So here's where I'm at. I have a positive 8.9 and I have a -7. There's 2 different signs, so I know I subtract. When I subtract, I get 1.9. I look back at my problem and notice that the bigger number is positive, and therefore my answer is going to be positive. So the real trick here is if you have a whole stack of numbers you want to deal with, it's usually easier to add the negatives together, get a negative, add the positives together, get a positive, and subtract one time at the end. We need to learn a new term. This new term is absolute value. Practically speaking, you can say that absolute value means to make what's inside these bars. Those bars are funny, aren't they? Those mean to be there, and they mean absolute value. You can think of it as what's inside the bars needs to come out, and when it comes out, it becomes positive. What we're really doing, if you think about it, or not if you think about it, what we are doing is we're asking how far from zero is what's inside here. So I want you to know that where the concept came from is we're thinking about distance. We're thinking about, well, -3 is 3 away from 0, and so is +3. So guess what? If I say, what's the absolute value of 3? So I put 3 inside these funny bars. They're just long bars. You can type them on your typewriter, by the way. It's between the enter and the backspace. You'll see that bar. So, and I just said typewriter, didn't I? Ooh, you can tell how old I am. Sorry, on your computer. So the absolute value of 3 does nothing to a positive number. It's 3. It's 3 units away from 0. The absolute value of -3 is also 3. It is 3 units away from 0. So I hope you see that all absolute value bars do, we call them that, absolute value bars, all they do is make something that is negative into a positive. It tells me that we use it when we're thinking about distances, and distances are never negative. So the absolute value of 22, 2. How about the absolute value of -34? Make it positive, 34. Now this one might seem tricky, and it is a little bit. This piece inside, I'm going to look at it first, and I'm not thinking about that negative on the outside yet. The inside tells me to make it positive. But then there's this extra negative here that turns it back negative again. So that, my final answer is -2.1. It was positive when it came out, then it became negative again because of that goofy guy right out front there. Last one, what's the absolute value of -1/8? +1/8. So be careful. Lots of students want to change the sign for an absolute value, and that's not what it does. If it's already positive, it stays positive. But if it's negative, we make it positive. So really, a better word for absolute value is make it positive. Let's see how complicated they can get. Sometimes there's more than one thing inside the absolute value bars, and I think you can see that here. If you focus right in here for a minute, look at all that stuff. We can't tell what's there until we've done that work. So we don't want to start making things positive yet. We want to look inside, do the work. When we get it down to one number, then we'll make it positive. So that's what I mean here when I say simplify first, then make it positive. Well, this problem's asking us to evaluate, and when we evaluate, they always give us a value to put in for the variable. So I'm going to rewrite, there's my absolute value bar, 4.2 minus 2, and it has an x here, but I'm being told to replace that x with 0.8. When things are sitting right next to each other, it means I need to multiply, and I'm going to write 0.8. I don't need to put that 0 in the front. And then I'm just letting, oh, I better put my other end of my absolute value bar. Sorry, here's the first one. Here's the second one. And then the minus 6.1 just falls right down. It hasn't been dealt with yet. So what's going on inside those absolute value bars? Again, I don't want to just start making that positive. What I want to do is do the problem first. So I'm just going to type it in. Seems the easiest for me right now. I'm going to say 4.2 minus 2 times 0.8. And that'll tell me that the value inside here, all of this, is really 2.6. I know that absolute value means make it positive. 2.6 is already positive. So really I don't change it, I just remove the absolute value bars. Now I have a basic subtraction problem. 2.6 minus 6.1, I can pop it in my calculator. I can think about that I know 1 is negative, the 6.1 is negative, the 2.6 is positive, so I know I need to subtract the two numbers. And I know my answer is going to be negative because 6.1 is bigger than this negative. There's my overall answer, negative 3.5. Again, you can have a negative answer when absolute values are involved, depending on what's going on the outside of those absolute value bars. In this case, we were subtracting. In another case, a different problem we had a negative sign in front of the bars, and that keeps it negative, even though it comes out positive. This guy is on the outside, and he happens after the absolute value happens. I think that's it. I think you're ready to go get your homework done. You have found specific function values and simplified polynomial expressions. Lots of big words there, huh? Don't forget to use your TOGA tutoring signs and our office hours. We want to help you out when you need help. Okay, see you later.